Hello friends, in this video we are going to study the relationships between the different current gains of three configurations of BJT, and these three configurations of common base CB, common emitter CE and common collector CC. And the current gain in common base is alpha, current gain in common emitter is beta, and current gain in common collector is gamma. Here, if you consider the common base configuration, the current gain alpha, it is equal to, we know that current gain is equal to the output current divided by input current. So that is why output current in common base is the common terminal, remaining two terminals are the collector and emitter. Collector is having more area, so that is why output, hence the collector current is output current and emitter current is the input current. So alpha is equal to IC divided by the I. Then if I consider the common emitter configuration, in common emitter configuration the current gain is beta. Beta is equal to, if you apply the same trick, IC divided by the IB. And in common collector configuration the current gain gamma, it is equal to the output current IE divided by IB. Now let us derive the relation between alpha and beta. So what is alpha? IC divided by IE, and beta is equal to IC divided by IB. So if I want to derive the alpha in terms of beta, I have to adjust the term IC by IE in this equation. So what I will do? Divide numerator and denominator by IB. So IC divided by IB, then IE divided by IB. So here we obtain one term IC by IB. At denominator, if you want the same term, I know that the total emitter current in BJT is always equal to the collector current plus base current. So that is why at denominator, what I will write, numerator as it is, at denominator instead of this IE, I will write there IB plus IC whole divided by IB, whole divided by IB. Now if you separate this, what you will get? The IC divided by IB divided by IB divided by IB plus IC divided by IB, and from this equation beta is equal to IC by IB, hence the alpha is equal to beta divided by 1 plus beta. So this is the relation between alpha and beta. Alpha is equal to beta divided by 1 plus beta. Now let us derive the relation between beta and gamma. So what I'll do, I'll derive the gamma in terms of beta. Here the gamma is IC by IB and beta is IC by IB. So here I want the term IC by IB in this equation anyhow. So what I'll do, I know that total emitter current, it is always equal to the base current plus collector current, hence I is equal to IB plus IC divided by total current, divided by this IB. If I separate this, I will get IB divided by IB plus IC divided by IB. Hence gamma is equal to IB by IB, it is 1, and IC by IB, it is beta. So gamma is equal to this 1 plus beta. And if you refer this gamma is 1 plus beta and alpha is equal to beta divided by 1 plus beta. So what I will get? The alpha is equal to, if I consider this equation and this equation, alpha is equal to the beta divided by gamma. So this is the relation which I remember. Alpha, it is equal to beta divided by gamma. Alpha, beta, gamma. Alpha is equal to beta divided by gamma, and gamma is 1 plus beta. So that is why alpha is equal to beta divided by 1 plus beta. Now we know that the highest current in transistor is emitter current, while the smallest current is the base current. So that is why if I consider these three current gains, alpha, beta, gamma, the highest current I, which is at the numerator in this gamma, while the lowest current beta, it is at the denominator in this gamma relation. So that is why the gamma is the highest current gain out of these three configuration, right? Then the beta, it will be less by 1 if you compare with it gamma, so it is moderate. And if you consider this IC is nearly equal to IE, but it is somewhat less than IE. So that is why this alpha, it is always less than 1. Alpha is always less than 1, and its typical value is from 0.95 to 0.995 based on the value of that base width. And this alpha is the smallest current gain in the 3 configurations. So this is all about the relation between the alpha, beta, gamma and their values. Thank you.